Today in Capechi's Corner, we're going to look at the converse of the Pythagorean theorem. The converse of the Pythagorean theorem states if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So our question is, can the following lengths form a right triangle? Well, we know in number one that our longest side, if it is in fact a right triangle, the longest side is going to have to be the hypotenuse. So I'm asking if 12 squared plus 9 squared is equal to, that's my question, 18 squared. Well, 12 squared plus 9 squared gives me 225, and 18 squared gives me 324. So that's not equal, so no, those lengths do not form a right triangle. And number two, we'll do the same thing. The longest side is 34, so if this is a right triangle, that's going to be my hypotenuse. So I'm asking whether 16 squared plus 30 squared is equal to 34 squared. Well, 16 squared plus 30 squared is equal to 1156. 34 squared is also equal to 1156, so they're equal. So yes, if we had a triangle with these lengths, it would form a right triangle. The Pythagorean triples are lengths of triangles that form right triangles, and they're common ones that we see a lot. We have 3, 4, 5, a 5, 12, 13, 8, 15, 17, 7, 24, 25. So if we see these lengths, we don't even have to use Pythagorean theorem. We know that they are in fact going to form a right triangle. Obviously, the longest side in each of these is going to be the hypotenuse. Besides these lengths, we can also do multiples of these. So this 3, 4, 5, another common one we see a lot is if I were to multiply each of those sides by 2. So this becomes a 6, 8, 10. Now again, the Pythagorean triples, the idea is if I were to use the Pythagorean theorem, 3 squared plus 4 squared is equal to 5 squared. I know in fact every time this is going to be true, so I don't even have to go through the computations. I know if I see 3, 4, 5, it does form a right triangle. As we continue to look at the converse of the Pythagorean theorem, we're basically stating that if c squared is equal to a squared plus b squared, then we know the measure of angle c is equal to 90, and the triangle is right. So if you look at our diagram, if I know that this is the case that a and b are legs, and a squared plus b squared is equal to c squared, then I know this measurement for angle c is going to be 90, and therefore the triangle is a right triangle. Now we'll do a little bit more than that. We can build from that. The next theorem states if c squared, so the longest measure, if that longest measure is greater than a squared plus b squared, then we know that the measure of angle c, again, the angle across from my length of c, is greater than 90, and therefore that triangle would be obtuse. Again, the reverse. If the other theorem states is if c squared is less than a squared plus b squared. So if the longest side is squared, and that's less than a squared plus b squared, then I know the measure of angle c is less than 90, and therefore the triangle is acute. Now remember, an obtuse triangle is a triangle that one of the angles is greater than 90 degrees, and an acute triangle is a triangle in which all three angles are less than 90. Now we want to decide if the following triangles are right, obtuse, or acute. So in number one, the first thing you have to do is identify the longest side, which is 15. So what I'm asking, I'm trying to figure out the comparison between 15 squared, and I want to know what mathematical symbol I need there. And then I have 11 squared plus 11 squared. They're the other two sides of the triangle. So 15 squared is equal to 225. 11 squared plus 11 squared is equal to 242. Because 225 is less than 242, this makes this an acute triangle. And number two, again, my longest side is 17, so I want to know the comparison between 17 squared and the sum of 8 squared plus 14 squared. 17 squared is 289. 8 squared plus 14 squared is 260. Because 289 is greater than 260, this makes this an obtuse triangle. In number 3, we have 8 and then 8 root 3 and 16. My question is 8 root 3? I need to always decide which side is the longest length, and I don't know for sure because I don't know the value for 8 root 3. So all I need to do is just put that in my calculator, and I know that 8 root 3 is about 13.9. So in that case, it's not longer than 16, so I know 16 is my longest side. So I have 16 squared. I want to know that comparison between 8 squared plus 8 root 3. Again, we have to be careful using my calculator, quantity squared. 16 squared is 256. And 8 squared plus the quantity of 8 root 3 squared, is when I add those together, I also get 256. So this is a right triangle. And number 4, I have 6, 8, 10. Now remember when we talked about triples, one of the Pythagorean triples is 3, 4, 5, and 6, 8, 10 is a multiple of that. So I don't have to really do anything. I just know already that that's going to be a right triangle. Now for our last problem for today, it says what type of triangle is triangle ABC, which is our big triangle. Is it right? Is it obtuse? Is it acute? So we need to do a couple things. I have the measurement of AB, that's 10. I also have the measurement of BC, which is 17, but I don't have the measurement of AC. That's what I need to find out. So in doing so, I'm going to use my smaller triangles. So if I look at my triangle to the left, triangle ABD, it is definitely a right triangle, and I have 8 and 10. My hypotenuse is 10. Now again, I'm going to use my Pythagorean triple. It's coming up again, 6, 8, 10. The same thing on my triangle on the right-hand side. I have an 8, 17 is my hypotenuse. And again, I know that the triple is an 8, 15, 17 triangle, so I don't even have to do any work with that. I just have to know my triples. So the measurement of AC, 6 plus 15 gives me 21. So now I can see that that's the longest side. So now I'm going to need to figure out my values. I have 21 squared, and then I have 10 squared plus 17 squared. So 21 squared gives me 441. 10 squared plus 17 squared gives me 389. And since 441 is greater than 389, triangle ABC is going to be an obtuse triangle.